conversion. What are the algorithms? Then right now I'm working on a project for digitization of ancient manuscripts, palm leaves. I will show some data files in the code. So what are the problem statements and what type of analysis we do on that? So those things. So actually, I wanted the laptop to stay my connection here. Given that connection is there, sometimes I will go there and talk in the mic. I hope if you don't see me on the stage, but if you hear my voice, is it okay? Let's start with that. So now my screen is coming. So what I will do is I will walk you through some parts of it. Well, they said okay not to see me. My voice is okay for them. How can I? My laptop tabs and they have to see the screen. That's all. More than me, they should see the screen. So basically, what I'm going to show here is artificial intelligence is a buzzword today, right? Several people are talking about artificial intelligence, right? So in order to use it for Sanskrit data related to Sanskrit, some kind of mathematical representation is compulsory. I will show what is that representation, and then I will walk you through some problem statements. There is this thing called vector-oriented thinking. So in some parts, I will come to the stage and I will appear. Some places I have to go to the laptop. So there is something called vector representation. The meaning is this. Are you familiar with array? Array data structure you are familiar with? That is extremely important when you want to create a machine learning problem statement. Want to use machine learning in your research, your exams. First thing that comes to picture is array. Array of numbers. Starting point. Because some more data is there. So you are able to represent your concept in the form of an array of numbers. Each and every element in that array will have some explanation. What do I mean by that? You want to represent a person as a array. The properties of that particular object you have to encode in the form. For example, if you take a person, got gender, male or female, 0, 1. Number is 0 or 1. So don't say that 0 is less. So it's called categorical attribute. So the encoding is in the form of subarray of two elements. 0, 1 means male, 1, 0 means female. So let us say a person has age. Age is a number ranging from 0 to 100, let us say. So it's an integer type of, maybe fractional as well. So is that sufficient for a person or is it not sufficient for a person? That question depends on what domain, what problem we are. For example, if we are recommending a product to a person, like in Amazon.com or Flipkart, when you are buying something, show some products to you. So how is it showing? The answer is this. They represent a particular customer as an array of numbers. So the array of numbers will are explained. In case of electronic commerce domain, they will capture what are the life events of a person. For example, a person may be newly married. A person may have a newborn in their family. So there may be some life event for that. Based on the life event also encoded. Among so many life events, which life event? 00110 or 0100. Encode the life event in the form of a one hot encode. Like all zeros and one in wherever that life event happened. So once you have a vector representation, this array is called vector, the machine learning world. Vector or tensor. So if you had brought notebooks, I would encourage you to write it in some of these words come a long way. So vector and array The difference is this only in, you know about speed and velocity, right? A scalar or vector? Scalar. Velocity is it a vector or scalar? So what is the difference? Vector has got some direction. There are extra properties creating the direction, and you are saying that it is a vector. In case of speed, only number is there. Extrapolates. Array of numbers. When you have an array of numbers, and if there is some meaning associated, direction associated, call it vector. An array with meaning. So a tensor is an. So in machine learning, for using machine learning in any domain, the first thing is how you represent your understanding of any vector of numbers. Once you represent as a vector of numbers, what happens? What happens is entire machine learning mechanism is the mapping methodology. It maps one vector. I give some examples. Given an image, I want to generate a caption saying seminar is happening, people are sitting, attending. So the input is an image and output is a sentence. So the input image is a vector of numbers. What are the vector of numbers in input image? Have you heard of 1 megapixel camera? This phone is having 1 megapixel camera or something like that. What is the meaning? A vector having 10 lakh measurements. Each and every pixel is a measurement. A vector having 10 lakh measurements is having RG pixels, having 30 lakh measurements R separately. So the input is a vector of numbers, can be 10 elements, 20 elements, or several lakhs of elements. Vector of the output is a sentence. So how can you represent a sentence as a vector of numbers? Can anyone tell me? If I give a word like how are you? How are you? There are so many thousands of. How will you represent how are you as vector of numbers? Can anyone generate ideas on that? Yeah, that's the correct word. Index. What is the representation? I want as an array of numbers. Sentence, I want it as an array of numbers. What is the array? That array, how are you? ARE, YYU, 9 letters. Case characters are also there. Are there? 9 plus 2 characters are. Now another sentence may be having larger number of. Where are you coming from? Okay. What is your native village? That is having different number of characters. How will you represent vector of numbers? So in machine learning, yes. So in machine learning, to design becomes a fixed vector of number or fixed vectors of numbers. Sentences are problem in a number of words is changing, number of characters not possible. On changing. Learning applied. Need an array of numbers. Now, what is possible is I can have array of numbers, but of such case of numbers variable in length. What do I mean by how are you is there? H is a character, is it not? A character. So English is having how many characters? 26 characters are there. So H is one of those 20. So you put 0, 0, 0, and wherever H is 1, remaining place all zeros. So what will be how many? 26 elements are there in the. So H is one vector in 26 dimensions. So these are called dimensions. The number of elements of the array is called dimensions. That's what I So now H is vector of how many dimensions? 26 dimensions. In that place where H is there, remaining place 0 is there. How means O vector is all 0, 0, 0, and wherever O is coming 1 and remaining places. So what is the vector? 26. How are you each and every character? 26. But how many vectors? How are you? 9 vectors. How are you? Space character is space also. Question mark or alphabet. 26 elements. Where are you coming of these things? So some length of some length. But vector is of fixed. Vector is a number of vectors. That is called the place where so corresponds. Having sequence of vectors of fixed sequence itself. That's okay. But within the sequence, there is a now the boils down to so many problems come starting point. Starting. Given a sequence of vectors, shall I map it to one of the categories? Type of sentence talking about. Given a sequence of vectors, can I map one sequence to another sequence or translate directly? Let us say we have a Sanskrit. Bhavataha nama kim. Not kim. Bhavataha nama. What is your name? How many characters are Bhavataha nama? Va, ta. Aha is with Vika, it's one character. Na, ma. Ava, taha, na, ma. Total 6. So, what is your name? What? 14 are. So, how can you map? Have to translate Sanskrit. What we have in our hand are sequence data. Have to first convert that entire thing to now. Bhavataha nam Sanskrit. How many characters are there? Aksharas. Total. How many bits there? Like ya, sa, you agree with alphabets? Us. So the so have 80. So Bhavataha namaki becomes vector of it's vector of 6 where each element is 80,000 dimensions. What is English? Some 14 are there. Element there is how 26 plus little. So we are mapping a sequence of 6 vectors where input dimension is 18,000 to a sequence of 14 vectors where input dimension is roughly about 30. Called language. So you have a database of hundreds or thousands or lakhs of pairs of which sequence is mapped to what. Then you can program that can map any sequence of characters in some corresponding English. Getting what I'm saying? Then you have a translation. So what I'm going to, I will go back to my laptop, some pages on that. But to do all of this, what is the starting point? What is the starting point in all of this? Vector representation is the starting point. Once we have something presented as a vector, then you can do wonders with it. Now, shall this vector be limited to language, or can this vector be any? Imagine a patient data you are capturing in hospital. So many sensors are connected. What are the sensors? And then pulse oxygen. So for every patient, for each vector of numbers, you agree? Vector of numbers capture measurements for and for 10 minutes. How many elements are 1 minute? You are elements will then vector dimension as many. Now this map to a category. So vectors map to category. Labeling in a sequence. Class itself is a vector. A good, bad, ugly. Health, take health. Moderately 1 to 5 category. So at any after some, so that one of the category 0, how many? There is a sequence having just one vector. One vector is what I'm saying. Now let us look at weather measurement. So you have so many sensors deployed in the city. Airport, you have 130 deployed throughout the city. And every 1 hour they are capturing. And you have measured. So how many measure? I have 130. So what is the dimensionality? 130 dimensionality. So every 1 hour I am capturing measurement. Okay. And I am capturing for 3 days. So total how many? 72 hours. 24 hours. So I have a vector. I will map moderately hot, cold categories. Those 12 they form a all zeros. How many elements are there in that vector? The sequence elements are so having just one element in that. So, so now vector sequence has got even more application. Autonomous talking about. So let us look at a vehicle, a car. Car. I want to check driver is crash or characterized. What are the measurements we are? Speed is one thing, clutch, how much clutch is, what is the gear level, what is the brake level, what is the accelerator, what is the pace at which that person is driving. That, for example, he's fast in, not go fast. Time of the day also matters. Rush hour, not rush hour, zone, school zone, school is going on and school is not going. All these are the form of a vector. A very large vector of having, let us say, characteristics. Now, captured these measuring for how many so how many elements are there, elements are there in the, now that six map it to driver behavior. And I don't need to map it to particular zone. Map it to next expected. What do I mean? On auto regression mode. Auto. That three. Auto means self. Auto means self. Driving or this. So if you map the sequence of it, next is what you have, your data. You can calculate. I have a sentence. This sentence, I read up to 11 words. And every word also calculate the dictionary number of dimensions. And every word is all zeros and one for you. So many words are there. Lakhs of words dimension on that. So who are you? Every word of 1 lakh dimension are there. Take a paragraph. You can map some 5 vectors. Yes, vector. One next. Agree with. I want to predict the next word. 5 vectors. Sequence of 5 vectors. Yes, 5. I'm going to, and I slide through the entire first to 8, 4 to 9, 5 to 10, and I predict the next word. That is called word to vector. By predicting the, so the sequence problems have changed the how language is. So word to vec paper, they give an example. Take a vector for each word. And man, take this word. Now take king minus man plus king vector, man vector. You will get that vector will be. Take this other alternative. India for the word India minus Delhi plus trans vector, get another vector, Paris vector. Exactly, the relations are learned. Exactly, these relations are learned vectors. So, talking about vector, are the first representation. So, vector representation has enormous potential. Okay? So now what I'm going to do is I will take you to my computer and I will show some vector representation. I hope you don't see me on the. Okay, if you don't see me on the stage, hear my voice. So let me take you. I try to uh, show on the screen Sanskrit translation. In that regard, I kept content in that. So there is some database called Itihasa, large corpus, large scale corpus for Sanskrit. So this was published in 2001. So this corpus, the raw data looks like this. This raw data, it's readable, right? You can really read it. No? So what I'm saying is it's full of Unicode. Okay. Somebody took trouble to translate it to some readable format. Yes. So after that, there is this person called Rahul R. Looks like everyone adapted to. So when you look at it, so how they prepared the corpus, right? The authors of this publication, uh, Rahul or authors. So they mapped Mahabharata and Ramayana for corresponding Sanskrit sentences to English. I have the data of English. Yes. So I tried to load it and then kept it as collab notebook here. I will just show you a couple. So you have to install some library, all of that. The sentences look like this. You can see this here. The ascetic Valmiki asked Narada the best of sage, and its corresponding sentence is there. Are you able to see this? So the training data, I have taken 0th sentence. What is the content of it? The first one is the corresponding some adhya, some. Now they have uh, several thousands of such data points. So the number of data. So in the training data itself, they have 72,000 odd. Data they have 11,000 and odd. When you sum them, how much is it coming to? Somewhere about 93,000 and odd it will come. 93,000 pairs of English and some sentences. Now, this data can be used at a given or given English. So let me walk you through data a little bit to give a glimpse of what is this. They have data in this format. Sanskrit. So before this data came, there were also kind of other translate. They used Bible itself is translated to Sanskrit. And Bible it they had this Swamiji's website is there from Gita, holybhagavadgita.org. Have English and Sanskrit. But more than that, I prefer, I like this. It has 93,000 odd elements. Sanskrit sentence, Ramana are there. So now, if you want to build a translator which takes an English sentence, looks as if Sage Valmiki. So, but what I am telling here is there is an opportunity to contribute here. Again, so spoken Sanskrit. So if you can create a data set of lakhs of sentences across all, create some hackathon, huge corpus of English funding, some we can have very spoken contemporary, some more of formation. Modern words are not there in one opportunity of creating. Hello. Okay. So recurrent neural networks or long short-term memory models are one way to map vectors to vectors, a sequence of vectors to a sequence of vectors. The sequence of vectors can correspond to English, other sequence can correspond to Sanskrit, or vice versa. This is one opportunity area. Creation of data set is one opportunity. Now what I'm going to do is, I will take you to another problem called digitization. Science Heritage Research Initiative. I have a project in that on how to digitize ancient manuscripts in palm leaves. I will show a couple of problem statements in that regard. So I will again go back to my screen and show some figures in that. So this is in collaboration with two. One is called Kanchi University. The other one is Banneri Amman Institute. Task is, there are documents like this. Can you see this palm leaf? Randha script, right? So this is the data set, sample data set we have taken and try to experiment with some of the algorithms I'm working on. So if you want to do optical character recognition on this, there are several challenges. Some of the challenges are how you segment the characters. There is something called segmentation. I will show what is segmentation on the screen. So if you see this character, what is this character? You don't know this. This is some character. I will show one character that I know. Okay. There is something called na. Na. So this is na. Can you see this na here? This na is there. Can you spot na anywhere else? This is also na. Can you see this na? Now this na character, na, capital N-A, is attached to the adjacent characters. Can you see this here? It's attached or not attached, right? So segmenting them is very hard problem. So segmenting isolated characters is comparatively. For example, if I want to segment this character alone, I can segment this because it is loosely touching the other one. It's not tightly touching the other one. If I want to segment this alone, it's okay. It's comparatively easy. So once I am able to segment the characters, the segmented regions will go to a classifier. First, the segmented character has to be represented in the form of a vector. Can anyone now tell me, I told something about vector representation, right? For a character, small image of a character, what could be the vector? Just guess what should be. Pixels, a measurement of pixels. So all the characters are of same size or different sizes? They can be of different sizes. Or all the subregions are of same, this is a subregion in this entire image. Call this as an entire image. This is a sub-image. Do you agree with me? Sub-image. Are all the sub-images of same size or variable in size? Wherever na comes, slight variation will be there, right? Some width and height may change. Now, the number of pixels, will they be fixed or will they be changing? They will be changing. So how you represent it as a vector? You can represent as a vector. What can we do on top of the vector? We can classify what character is it. That is called image classification problem. Image classification problem is given an image, telling what is that image. So if you can represent an image as a vector of numbers, then you can tell category also as a vector of numbers, and only for that category 1 will be there, remaining all 0, 0, 0. Getting what I'm saying? So for na, the character na here, you can see this na here, right? Na. For this na, the number of characters could be any number, right? The entire vocabulary comes into picture there. This na is one of them. Na is one of them. Is it recognizing? Wants me. Yeah. Yeah, yeah. We will discuss that. No. I will show some results on. So, one of the things I was addressing, in case of joint characters, in case of letters, or it can be word patterns also. Given any word, can I set a problem statement? What I am currently working. I will give any pattern as query. You see this pattern here. So this is my query pattern. The query pattern can be a single character, or it can be a word, or it can have any amount of dimensions. It can have variable dimensions. You can see this query pattern. Now the task is, how will you search for a given query pattern in a larger document? The query pattern can be image of a person also. The query pattern can be anything. So how you search for that query pattern in a given image, it's not pixel to pixel, something more than pixel. You have to look at the context of the loss function is the loss. You have to formulate a loss function because wherever that query pattern. One thing I'm doing as part of one project called Science Heritage Initiative. So as part of this project, so one of the things I'm looking at was digitization of manuscripts, palm leaf data. So on this, for example, um, on this, I'm trying to show here. So if you see here, are you able to see those small boxes coming somewhere? I drew some small boxes. Here, boxes are there, right? You can see this box coming here. You can see one box here. Can you see these boxes? They are very faint in color. This box, one box is coming there. Some false positives can be there. Some false negatives can be there. You see one more box is coming here. Even any pattern, irrespective of the language, very problem. I have been testing it on different data sets. This is another palm leaf. You can see those boxes somewhere here in this document. Somewhere also these boxes are coming. Paint box is there. Not sure if you are able to see with your eyes. Paint box is there. There is one box here. We search, we'll find. So this is one false positive. This is some wrong prediction it is getting. One box it is got. Here it got another box. This is also false positive. So are there some other boxes? So like this detects some boxes. Okay. So let me show you a couple of document where these characters are more. If the characters are more, we will see more boxes. Otherwise, we have to search with your naked eyes. You are not able to. I am also not able to properly, but I am showing boxes coming. So I will see. I'll try to hit Control plus. Let us see Control plus work. So let me do Control plus. It is coming. It is. Can you see those boxes here? Boxes here, some overlapping boxes, another box here, another box here, another box here. So some false positive here, some false positive here, some correct predictions here, some boxes are correct, some boxes are correct here. Basically, what is happening is, this is also a very important problem on how you segment the characters. It's an important problem. So how you apply it for different types of data. Right now, I started with Grantha scripts, and also Bannari Amman Institute of Technology. They have Tamil manuscripts on palm leaves. How you detect those specific characters? So the approach what we are taking will go with their legacy platform. There is something called legacy platform. Legacy platform means their existing programs, whatever programs and team they have, we will not disturb it and we address their pain points. Means on top of the existing, they have some difficulty to address. Particular characters it won't recognize. Their existing. Those things we will do algorithm and we will value add on top of it. So this is the approach we have taken. So that everyone feels win-win. Like if my algorithm comes and says you replace yours, then there is damage of this. So this is how projected the problem. Their pain points we will fix. And so for Sanskrit also, if palm leaves are there, we can co-work. Gentlemen, your name? Sanket. Sanket's algorithm, we can, whatever it's having trouble or something like that, we can try with this, like that augmentation mode. Based on data, how co-work can happen. So this is one important problem. What I'm trying to say is the problem statement here is to be able to build a general purpose system, such as, let me show you the HRI document. Nice heritage. Let me take you to, just meet with me for opening some. I call this algorithm platform as Sri Akshara. So we have some working codes, all of that. Can we create a semantically searchable interface? Like if we are able to take some text and show the origin of the text in the original documents in a semantically searchable interface, such as not only take characters, any subregions also we can be able to search. The expectation is crowd-based annotation is possible. There are several scholars available, but they are not having right tools to give their knowledge to the system. So have a system or tool in place where they can mark some regions and provide annotations in real time. They can build models in real time. Will enhance the knowledge base Indian tradition space. So what I will do is I will go back to my presentation slides and I will show you the machine learning slide what I have. So I will just stop here. This to apply machine learning, the first and foremost thing required is vector-oriented thinking. We have to start thinking of whatever we see, whatever we observe in the form of vectors. Once we are able to do that, machine learning methods are available to create very good problem statements. So with that, shall I stop, or half an hour more I can continue? Means I can continue and take other slides. What is the audience opinion? Stop or continue? Yeah. I did my speech such a way, any time to stop, any time to continue, that much time. Then I will stop. Service is okay. I will just continue. Whoever wants to carry on, they can carry on. No. So this slide, I need some help in hitting the next button. Can you the next button? Anyone? Thank you for accepting the request. So go to the previous slide. Page up. Yeah, this one. So this vector representation has mathematical importance. You see that slide. You saw so many confused, right? Why are they confused? For different reasons they are confused. Basically, they are having set in their mind. A set is an unordered collection of items. For example, if you want to do some tasks, if you don't order them in particular order, will you not be confused? Definitely, people will be confused. So, a set representation is responsible for their confusion. Now, if you look at list representation, can you go to the previous slide? Yeah, set versus list. List is the representation. Will they be confused? It's an ordered list. How will we know the order? So, I want to, you are hitting next, madam? Okay. So, please hit next one, next slide. Yeah. So, this list representation occurs in several different ways. One of the ways is called diary. D-A-I-R-Y. That is same as the cow diary? No, right? So both are different. So basically there is something called thought diarying. How you organize your thoughts in the form of a list of thoughts organized by priority and time. That is called thought diarying. So if you see here, time slicing, you dissect your any timetable we take. Let us take academic section, they prepare timetables, right? Let us say they run the show without timetable. Is it possible for them? Every teacher will be trying to come to the same class, bombarding, hey, you are taking, I took. So it will be fun situation, right? So what is the timetable? First point. Timetable is nothing but ordering the same topics with respect to time is timetable. So a list representation has got tremendous amount of advantages. Set versus list. Set means fight. Set for fight. List means you soften things out. So here I'm showing some examples of list representation, like time management, process management, okay, and organizational behavior. Organization is also split into several departments, right? Why do they split it? Why can't they have all the departments as one unit? Let everyone fight for their funding, right? So they dissect it into several subunits. So that is the purpose of list. The next button. So where is this vector oriented thinking coming into picture? The idea is it's a new paradigm. It's a new thought paradigm. Till now, there are some 4 paradigms. What is a paradigm? Paradigm means is a mechanism, tradition, habit. All of these things come under paradigm. So you have computational thinking paradigm. Computational thinking paradigm means step-by-step reasoning is processed in computational thinking. Flowchart. So take any person. I'm not sure how am I. Like artists, they say typically they are not ordered. I don't know. I have to verify that. So engineers, they say they are very much ordered like this. General. So what do we mean by that mindset of being ordered and not ordered? You are able to dissect your task into several steps and sub-steps. You are automatically applying that. Engineering is not a role. It's not a job role or anything. It's a methodology. You are able to apply any problem into steps. Like how do you put elephant into the fridge? Let's say, put the elephant, open the door, and then close the fridge. Like that's not the order, right? So you have some steps for that. Elephant, the door, close it. So whether possible or not possible, also, if you are able to put it into several steps, that methodology is called computational thinking. The second methodology is called object-oriented thinking. So object-oriented thinking means Java, C++, you heard of it, right? So this word object also looks like object. Court, you say objection, your honor, they say, right? With the full force they fight, objection, your honor. So that I'm not talking about that object. Object means stop. I'm not talking about that. I'm saying object. So if you want to use machine learning methodology, you should be able to identify all conceptual objects. Let me tell you what is a conceptual object. I'm talking, right? Talk, is it a verb or not? Talk it's a verb. Can you make it to adjective form or noun form? I'm walking. I walk from, walk is a verb. How do we convert this verb to adjective and noun form? Talkable object. I create a talkable object. Talkable object, is it a noun? Talkable space hyphen object. If I write it as thing, a noun or not? Talkable object is a noun. Talkable is an adjective. Talkable item. Yeah. Runnable, walkable, talkable. All of these are interfaces in Java. Java program have this interface. An interface is a noun-related conversion of verb. So that is the starting point of creating machine learning problem statement. Let me tell you how it is. Let us say I walk from A to B. Now, walkable is an object in that. Walkable is a type of object. Walkable object is a type of object. Now, where is machine learning coming in? There is a surface that is providing walkable feature. There is a person executing that walkable action. Now, am I walking on ice floor? Can I just walk like this? I will fall, right? Now, for walking on ice, I need shoes of different type, like this spike should be there. Can I walk just like this in sand? So, for walking in sand, different types of shoes are required. Can one man not having legs walk? What is walkable for that person? Having one person having only one leg, how does that person walk? So, these surfaces are also, if the distance between A and B is very high, let us say it is Everest. B is on Everest and A is ground of Everest. Can I just walk up the Everest like? So, this walkable object has some properties associated. What are the properties? The GPS coordinate, type of the surface, season. Can I just walk a surface in rainy season without slippery? So the properties, once you identify a verb as an object, able to identify what are the properties you can define on top of that. Once you are able to define the properties on top of a verb, it is converted to noun form. That becomes a vector of, you agree with me? Like how we discussed the previous one, it becomes a vector of numbers. Once you have a vector of numbers, eligible for being in a machine learning world, is the first eligibility criteria for it to start living in the machine. What is the other thing? Person itself. Person, what are the walking tools a person has? Is he having those spike shoes? Having these kind of for icy surface, spike shoes are the mapping criteria for that. Is he having different, is he having some physical condition? Does his physical condition enable walking? So is the walking distance, how much is the distance that person needs to be capable of walking? All these properties will start to recognize once you are able to present verb also and as a, so object oriented thinking is about that. How you change your thinking paradigm to see objects everywhere, not only in the nouns, but also in the verbs. Once you start to see the objects everywhere, you're able to represent them as a vector of numbers, and you are able to map a walkable surface to walkable person, walkable surface to talkable object, a talkable person. For example, talkable, I talk, I'm talking, right? Talk is the verb in that. So, talkable object, if you take, how am I talking? Am I talking to the mic or am I talking to the audience directly? Interface comes in, or am I talking in back? Talking back, how much ever I talk, the person. That's also possible. Algorithms are. So, the second paradigm is object-oriented thinking is full of these kind of interesting representation. Third paradigm is process-oriented thinking. So you have heard of these Amazon Web Services, right? Amazon Web Services are there, Azure Web Services are there. Everywhere, whole world is in living in service environment right now. Paytm, Google Pay. So, can you see a process everywhere? That is called process-oriented thinking or service-oriented thinking. So, for example, I want to recognize some characters. I want to segment some characters in image letters. Now, your thinking paradigm, service-oriented world, can I give it as a service? Can I develop an API, takes an image as input and segments some characters and gives as the output, all the segmented characters. And he may be gaining some revenue also on top of running it company. So service-oriented or process-oriented thinking is another paradigm that there in the world. There is one more paradigm called table-oriented thinking. Can I see the entire world as tables? There are tables here, for example. That's a table. That's a table. I'm not talking. That's also a table, right? I'm not talking about these tables. I'm talking a table means a columns and rows. Excel. I'm talking about an Excel sheet kind of a representation where you have those tables. For computer scientists, it's table. Go to furniture It's not a table. It's some data. So I'm talking about that type of table where you have columns and rows of representation. This is related to databases, schemas, how you store the data, how you modify the data. The entire database systems map to the table-oriented thinking. Now you have something called key value pair system. Additional variations are, but predominantly table-oriented thinking is this. Now in the for the Dosta Chatushtayam should we? No. in the gamut of these four things, right? Of computational thinking, object-oriented thinking, process-oriented thinking, table-oriented thinking. Now you have one more guy coming into picture called vector-oriented thinking. So if you can represent the entire world in the form of vectors, then machine learning methodology can be safely applied there. The vector-oriented. Next slide. So this is about is a vector possible? The question for that so I'm not a neuroscientist. Just this is one figure to show any thought, anybody having any thought, any thinking can be represented. Agree with me. Don't just agree with me. You really feel we can represent a brain as a vector of neurons and neuronal connections. It can be very large. Okay, let it be large. Take the brain as a data structure, as very large vector of elements. Each and every element corresponds to either a neuron or neuron to neuron. May go from here to moon, that's okay. It's okay. So, any thought state going on in the brain is not a vector representation. 0, 1, 1. Neurons are active. This agree with me. The measurements are dimensions. Dimensions are same as what are the measurements, what are the observations. Image, 1 megapixel you take. How many pixels are there? Mega means 10 lakhs. 10 lakh measurements are the dimensions. Have a color camera, neurons, very large. But it means mathematically large. Large number is large. Okay, but we are not just in the vector in that large dimensional. Now, if you take a computer you take 2 GB RAM or RAM, it is. Now, the entire state of the computer itself, excluding hard disk, let us say hard disk, can be represented as a vector. Do you? Why? Because you can represent each and every measurement happening in RAM. 2 GB means 2 giga. It's 2 power 30. 2 power 30 elements are there, where some are zeros and some are ones, and processor is also having some zeros and ones, program counter, registers. Concatenated with that, it becomes a large vector, having certain zeros and ones. Agree with me? So it's a finite state. So it's a finite state machine going from one state to another state and modifying the contents of the RAM itself. So anything can be represented as a vector. Some thought can be fundamentally represented as a vector. Maybe very large, but still you can think a smart way to reduce the size of the. So next slide. So next slide. This is related to that only. Yeah. So anything happening in the mind can be represented as a vector. I was giving some thought exercise. I will skip this. Slide means it's a PDF, so page down it will come. So RAM chips and all I have put example. Next one. Next one. So this, just let's hold on this. So this is the vector I am talking about, representation of zeros and ones. So I will walk you through some loss function, some representation. Given a vector, the task is to map it to another vector. Problem, right? Machine learning, the pipeline boils down to this. You have something called x vector, you have something called y vector. Y is equal to f of x. F is the mapping function from input vector to the output vector. This mapping function comes with something called loss function or cost function. You want to minimize the cost function with respect to the parameters. In learning, the pipeline is to start with some initial values of parameter, have some loss value initial, and in every iteration update the parameters. That mapping becomes more clear or improves, the mapping improves. What sense? Loss, in the sense of that loss value diminishes. Loss of mapping input diminish over several iterations. This is the fundamental paradigm in machine learning. I will walk you to a couple of problems. So this all I'm skipping here. I will explain about where are vectors here, where is loss function, and on top of this, and are you, which line is good? I just showed some slides and I'm asking, in your intuition, which line? But where are vectors here? Correct. Green is good. Green is correct. So now let us apply some machine learning thinking to that, vector-oriented thinking. How this problem is, I'm going to explain. So everyone agrees green is good? Everyone agrees green is good? Good, visible. But where are vectors here? Every circle you and every see is a vector. Agree with me? Vector of how many dimensions? Particular figure. One dimension only. One point at this offset in x, and every x is one dimension. What about y? Is also one dimension. It's also one dimension. Along this line, each and every point has got one y value. You are mapping one dimensional, mapping one dimensional. How are we mapping? We are mapping to loss function. What is that loss function? That should result in one of the lines. So, what is the equation of the line? Slope and intercept. Y is equal to, so C constant. That also we have to figure out which. Like if I write a line, y is equal to passing through 1. Not passing through origin, offset with -1 means some. So loss function is defined here. Loss function is, I will show one very simple law. Y is equal to mx plus c is called the mapping function. How you map x to y. Okay? And the loss function here is shown in the form of squared error. yi minus mxi plus c whole square. This is called squared error. So this loss has to be minimized. We start with some values of m and c, and over iterations we modify the values. So this methodology is called gradient descent methodology. Start with some values of m and c. Y is equal to mx plus c. You start with some values of m and c. In every iteration, you keep on updating the values of m and c such that it reduces the loss function. So if you look at the machine learning methodology, I will stop in 2 minutes. I can do the face reading, okay? Use it to face reading. Hey, my students, I will just show this slide and stop here. So machine learning has got 5 important steps. The first step is how you design your input vector, X vector design. The next step is how you design your output vector. The third step is how you design your mapping function, f of x. The fourth step is how you design your loss function. Is it squared error, or you can have your own customized error function. The fifth step is how you create your data set. These 5 elements, they apply to a particular domain, they lead to some PhD thesis also. How they design their X vector, Y vector, and I will stop here. Any questions are there, I will ask. 1000 to 30. Sequence. That is using another methodology called recurrent neural network. So here, X is not one vector. X is a sequence of vectors. Y is a sequence of vectors. How you map one sequence to another sequence, I will tell the methodology. I will tell rough idea of the methodology. You take each vector, multiply with a matrix, and generate one intermediate vector called H vector or latent vector. Use it as input for the second vector in the element, generate the updated H vector. Use it as input for the third vector, generate the updated H vector. You recur through the input and keep on accumulating the H vector. Hidden layer, yeah. So you have this thing called context. How much context to retain? Should we want to retain the first word itself in the sentence, or we want to purposefully forget some words? That's called forget gate, next gate. Like that, some configurations are there. So vector to vector mapping is done in that through a latent mapping and using it as input, recurring through the mapping. Any questions? Okay. Any questions are there? We'll be happy to ask a question like, when is the talk ending? Okay. Yeah, it's even. Thank you, everyone.
Oh, Ravi, come. One table. Chair పెట్టండి, chair. Thank you very much, sir, for your wonderful presentation. Much knowledge acquired by each and everyone. It's a good presentation and needed one on. So I'm requesting additional convener, and today's chief guest come on to the dais, please, for few minutes. Now I'm requesting convener sir and additional convener sir to felicitate our keynote speaker. If you I'm requesting Professor G. Sridhar sir to give vote of thanks to our keynote speaker.
So it's a great privilege for me to give vote of thanks to this esteemed professor from IIT, Professor Kaldas sir. Sir, we are very much impressed your live lecture and with your whatever you have done the research presented in front of us. And we from the National Sanskrit University, and from our students' point of view, we want to join your research work, sir. Our students are very much interested. So kindly give opportunity for them for the internship, sir. So, so we are very much thankful for your presence and giving the nice presentation. So thank you.
Thank you very much, sir, once again for accepting our invitation. Our students are willing to take one photograph with you if you are accepting, please. And 5 minutes break, ma. Only last small break. Don't mind. Please have a cup of tea and come back here. We will go for lunch by 1 o'clock. Please, don't go anywhere. All the students, I am requesting you. Please don't go anywhere. Go and cup of tea in outside only is there. Please come back by